All right. Today is June 7th, and this is the 2016 Facilities Geospatial Technology Showcase. The second annual webinar series is hosted by the Campus Facilities Technology Association and organized by the University of Kentucky. I'm Lauren Weaver, and thank you all for joining us today. Today's webinar is being recorded. Both the recording and slides will be made available on the CFTA website. The presentation is estimated to run for about 45 minutes with the remaining time open for Q&A. Feel free to send any question you have during the presentation using the questions dialog box or by raising your hand. Your question will be added to the queue and answered at the end of the presentation as time allows. I'd like to extend a big thank you to today's presenters from the University of Arizona's Planning, Design, and Construction Department. Grant McCormick, GIS Manager, and Drennan Brown, Assistant Director for IT and Spatial Services, will be presenting their Enterprise GIS and its role in public web maps as well as internal projects. Thank you for joining us today, guys. The webinar is yours.
Thank you, Lauren. This is Grant McCormick, and I'm going to start off with the first part of the presentation today. And we're going to generally go from a broad view, kind of an organizational view of our Enterprise GIS with a little history, and then get into more of where we are today with our configuration of this system, and then move forward with some more detail, a deep dive on some of the technical projects we're working on. This is a quick overview of the University of Arizona. We are at the main campus in Tucson, which is the focus of our GIS work. And we have 2 branch campuses and numerous other sites around the state. This is the org chart of our department, and which is Planning, Design, and Construction, which is sort of a sister department on this campus to Facilities Management, Parking and Transportation, and a number of other departments that report up through the Business Affairs Division. Circled in yellow is the Spatial Services and IT Division within which the GIS is housed, and there's about 12 FTEs in the Spatial Services Division and about 4 now in the GIS area. And I have been with the university for 21 years now. So as I mentioned a moment ago, this is the outline of what we'll be talking about. Some background on the GIS to give an idea of how we've got to where we are today, and then some of our current and future projects. So the idea of an enterprise GIS started close to 25 years ago within the campus planning department at the U of A, which at the time was a small 6-7 person unit. During this initial phase of the GIS, which lasted around 15 years, it functioned primarily as a departmental system, again housed within the campus planning unit. The vision for the spatial data management system, or the Enterprise GIS, was outlined in a report produced in 1992 by U of A GIS faculty members. It took several years, but an outgrowth of the report was hiring the first GIS staff member, and I don't look like that anymore, incidentally. So next, during the period of 1995 to 2000, one of the first actions that was taken to build the GIS was obtaining funding aimed at creating a base map and other layers and a set of orthophotos for campus. The current Enterprise GIS data has evolved directly from this original mapping. Another action taken was to organize a broad campus initiative aimed at creating an enterprise system for spatial data. Many meetings were held, systems inventoried, and so forth, but the involved organizations and leadership at the time was not really poised to bring this about. So after several years of work, the energy dissipated for that effort. One of the challenges was that since the GIS started within the campus planning group, the effort did not have more extensive resources that might be found with a larger department, and not being an operational unit that managed physical resources, its range of potential applications was limited. Since physical plant systems and resources were not managed by the department, the ability to automate operational processes via web maps and so forth was limited. Nonetheless, the GIS was used for numerous campus planning and one-off custom mapping projects through this time period. One successful aspect of the GIS during this time was the creation of the university's first interactive GIS-based web map. This was a collaboration with the university's central IT department, and it resulted in a resource that was in service for over 10 years. And then in 1999 at the Esri User Conference, we presented our experiences at the UA with establishing GIS as a tool for university administration. And despite many successes we'd had, we weren't able to report much progress toward an enterprise system. By that point, our first enterprise initiative had pretty much faded. This UC session drew interest, but not a large crowd, perhaps 15 or 20 people. It was clear that GIS for this particular use at that time was sort of a small niche. So then during the period of 2000 to 2005, as an outgrowth of my 1999 UC presentation on GIS for university administration, I was asked to contribute a chapter to a book on university use of GIS. My experience as well as research I did for the chapter did not yield any silver bullet solutions to the question of creating enterprise systems, but it did allow me to analyze and present many of the challenges and contextual aspects of building a GIS within the university environment. An outgrowth of writing this chapter was renewed interest in creating an enterprise system, so this led to the second major initiative, roughly from 2004 to 2006. But again, significant inventory and assessment occurred. Committees were formed, proposals created, and so forth. And like the first initiative, we tried to get organizational buy-in, build consensus, develop a cross-departmental vision, and so forth. More of a top-down approach. And similar to the first initiative, energy eventually waned due to staff changes, departmental territory issues, and lack of appropriate champions. During this period, the GIS was used extensively for custom maps and campus planning. And so here are a couple examples of some of the types of custom maps that we do, have done many of, and continue to do. On the left is a visitor directory map that's used in wayfinding kiosks around campus. On the upper right is a guide to rides and activities at a student-run carnival that's held every year on campus, and the lower right is a development analysis of current and proposed density on campus. During the period of 2005 to 2010, the GIS continued to be primarily a departmental system used for custom maps and campus planning. And then in 2008, the campus planning unit was merged with the design and construction department, which formed planning, design, and construction. One outgrowth of this merger was a new effort, again, to create an enterprise-scale GIS service. In this case, initial seed funding was awarded, and a strategy different from earlier initiatives was created that focused on just getting started building the system, looking for small incremental successes, and not waiting on larger institutional departmental buy-in. So with this seed money, it really started on us on a path to doing a demonstration of an actual enterprise system. So during the period of 2010 to 2015, with our seed money in hand, we began developing our demonstration enterprise system on several parallel tracks. One was converting our legacy shapefile-based database into a file GeoDatabase, and then into an enterprise multi-user GeoDatabase. And the second main track was creating interactive web maps that would get the GIS data in front of the campus community and demonstrate the value of a common source for geodata. This resulted in 2 Silverlight apps, which were very successful and are just now about to be retired. As it turned out, shortly after we committed to the Silverlight platform for these apps, the first iPads were released. And then by the time we launched these apps, the writing was on the wall about the future of responsive mobile web apps, which guided a change in strategy for our next round of web maps. We've utilized several labs within the College of Agriculture and Life Sciences at the U of A, along with Tucson GIS consultant Tierra Systems Southwest, to develop our web maps and database. We also employed students to help with the project. A bit more than a decade after our first presentation on University GIS at the Esri UC, I presented in 2012 on our current efforts toward an enterprise system. At this point, there were many more promising developments to report on, although we still weren't configured as a sustainable service yet. But by now, the level of interest in the current phase of implementing RCM, or Responsibility Centered Management. RCM is a transparent, decentralized budgeting model. In addition to aligning with the university strategic plan, a key element, which will be described more later in the presentation, is that under this model, units are charged for their space, therefore building in an incentive for efficient use of space. In 2013, building on our initial successes, we were awarded a second increment of seed funding from University Administration, which has supported subsequent application development. In 2013, we developed a new JavaScript-based map for identifying information about major capital projects on campus, and then began work on our flagship web map, Campus 360. This is our Swiss Army knife type of app with many layers and many tools, and is focused on U of A employees. And then during the spring of 2014, within about a month of each other, we successfully launched a full release of Campus 360 along with 3 additional maps: the U of A main public map, the Arizona mobile map, and the U of A impact map, which we'll talk a little bit more about later. And for the GIS program, at this point, this was like hitting a grand slam with all of these maps coming out at once. This is shows a little bit on these maps, and we just wanted to point to where you can go take a look at these if you like at maps.arizona.edu. All of these maps are linked. So during 2015, a number of pivotal things happened related to the enterprise GIS. One was that the College of Agriculture and Life Sciences developed a application to demonstrate the use of space information it was really driven by the need for the RCM budgeting that was coming up, and this was something that drew on our applications and merged space database information in, and this is something that's really elevated the visibility of the enterprise GIS, this is something that Drennan is going to talk about a little bit more in detail as we move forward through the presentation. Our approach to incrementally building small successes, obtaining additional resources, etc., had worked, but we still at this point did not have sustainable support model for the enterprise GIS. We had succeeded in getting content to the campus through web maps, and we had created a framework. So then in October of 2015, the Department of Real Estate Administration was merged with PDC. Real Estate Administration was responsible for managing the U of A's real estate portfolio, along with managing the U of A space inventory. This shift was significant in that it created a second major spatial arm to the department, broadening the department's mission and allowing for significantly enhanced collaboration between the university system for managing space data, which is Archibus, and the enterprise GIS. And on the heels of the merger, 2 new employees were approved in December. This was a goal we had pursued through different avenues for over 5 years. So with these positions approved, we feel that this will now allow us to move beyond the enterprise system demonstration phase and into the full implementation of the U of A enterprise GIS. So since 2016 has begun, we have hired new GIS employees, a developer and an analyst. And among our first priorities have been to upgrade our infrastructure and undertake code modernization on our applications. Additionally, we've got a couple of projects that we're focusing on, including a sustainability GIS database and web map, and an Arboretum grounds field application, and some 3D building work, along with utility mapping and developing data and apps for room level mapping. And so that's what we're going to talk about a little bit more later in the presentation. So in terms of the UA Enterprise GIS today, I'll talk a little bit about what we have today before moving on to the projects. So the Enterprise GeoDatabase that we have in place is a key component, or perhaps the heart of the system. It's a multi-user, multi-editor Esri SDE database based on SQL Server. Our model is for the database. Our model for the database is to be the university's common spatial data resource or hub for data maintainers, for map makers, analysts, and as well as for map applications and other data systems. We envisioned and created a model whereby data owners are distributed throughout campus that maintain their spatial data within the Enterprise GeoDatabase in order to leverage the many benefits of a shared common source. Several departments are currently operating this way. So the Enterprise GeoDatabase is organized into 7 SQL schemas shown here. The vast majority of this data is considered public, with some of the structures and utilities information considered sensitive. In terms of our web map applications, that we're going to show the framework for publishing them. We start with our Enterprise GeoDatabase, and that gets exported to a read-only copy in file geodatabase format, which is then used to author our map documents to create our services. So we send the data and we create the services on a test server, and from there, once things are checked out, we publish to a production server, and from there then we basically send the code to the web server, and then that and the application code is then presented to our web applications. So that's a really quick overview of our workflow. This has served us pretty well overall, although right now we're starting to explore ways to make it possible to keep data more up to date, more current, and also ways to allow direct editing from web apps into the database. So in terms of what we conceive of as the Enterprise GIS, this shows kind of our idea for it. Our vision for Enterprise GIS shows the diverse types of needs our existing applications have served. The Enterprise GIS cuts across so many needs, and it's in this sense that we consider it to be an enterprise system. Given a variety of factors, our applications have tended to meet more of the needs that are shown on the right-hand side of this diagram, and with our new staff resources, we expect to put much more focus on some of the functions that are on the left side of the diagram. We've made the case that a common enterprise system is needed to avoid such diverse needs being met through a myriad of splintered, disconnected, and ad hoc solutions. We highlight the risks of everyone doing their own thing and not having a coherent system. These ideas have been really key in our support pitches we've made to upper administration. So this is a list of some of our current projects, data, services, and applications that we're working on that we'll review in the next series of slides. And so let me go ahead and jump into the first one. So we're starting on a sustainability web map and database. And this is an example of the type of project we develop with campus partners, not only to meet the needs that they have, but also to help build support for the Enterprise GIS. We acquired these project funds for this project through a student-funded IT fee, and will develop and host the data and application as part of the Enterprise GIS. The Sustainability Office will then become the owner of the application. This has been part of our overall model of building support, partnering with campus units that have mapping needs, working to obtain funds, collaborating in the creation of the product, and then hosting the results. With this project, we're at the point of moving from design to implementation. The diagrams shown are on the upper left, a mock-up of the web app, and the lower right is a data brainstorm diagram. We expect a prototype app to be available this summer with final products next June. Another similar app that we're working on is the Arboretum grounds field app. This is a partnership between the Campus Arboretum and PDC, the Enterprise GIS, and Facilities Management. The Campus Arboretum has been a long-term partner with Enterprise GIS and has housed their collection in the database for many years. So in addition to partnering with CAL's Facilities Management, the Arboretum, the Enterprise GIS, we're also partnering with the Institute of Museum and Library Sciences, which was the granting agency for the funding for this project. What will result is a field data collection and maintenance app that will allow staff to directly update grounds records from the field, in some cases eliminating the need for older spreadsheets that are harder to maintain and integrate. The image on the left is from the current Campus Arboretum web map. The technology and data used here will be built on for the grounds field app. It's expected that this will create efficiencies and more effective reporting for both the Arboretum and for grounds. And on the right is a preliminary sketch idea related to the future app. We have not really had resources available to develop an overall 3D GIS strategy at this point, but what we have done in anticipation of an eventual 3D effort is gradual development of 3D data within the GeoDatabase feature classes that we have in our system. The focus to date has been on defining accurate floor and ceiling elevations and articulating roof forms and elevations. This effort is characteristic of how we have approached much of our data development in the context of very limited resources. When our schedule permits, we've gradually invested in data creation we believe will pay off with key partners in the future, while not devoting an overabundance of time to such efforts if there's no clear current project need for the data. In addition to laying groundwork for future applications, the basic 3D model we've created, shown above, is expected to be used for a range of purposes within our upcoming campus master plan update. Another effort that we're undertaking right now has to do with utility mapping. On the right is an Esri data model. We use these for ideas, however it's hard to imagine us being able to fully implement one of these models. This observation is in response to the reality of resource limits and organizational issues. It is unlikely that we will ever have the amount of resources to build and maintain such a fully fleshed out utility model. And since we're not the organization that operates the systems, we're not in a position to wire the GIS applications so as to function in concert with operational systems, with automated controls and so forth. Our approach is indicated by the utility typology on the left that we're using as a guide. This is a simple categorization of each utility type with components for each and the type of structures the utility is contained in. It's a simple listing of all utilities serving campus that we would like to include in the GIS. For department-specific needs pertaining to utilities, the primary goal for us is to define where components are and what they are. We expect that by accomplishing this goal successfully, we will be able to leverage further partnerships in the future that will see the Enterprise GIS data used more for operational management purposes. Many standalone CAD drawings of various utility systems exist, and we expect to utilize them where possible. But for the most part, these drawings are project-driven and not maintained as a living record of the system. So simply importing them into the GIS is not a complete solution, given that they are often not spatially accurate or out of date. In light of this, one approach we are doing is using existing documentation, such as this tunnel report here, to build our information. This includes a wealth of information about systems, including photographs and tabular data organized around tunnel structures, such as vaults and indexed by tunnel cross-sections. This diagram shows information that a consultant has pulled out of these tunnel reports for us and organized into a format for importing into the enterprise GIS. And this is how we've started to build our tunnel layer within the GIS. This information at this point has been completely imported and will be useful in verifying and mapping individual utility lines. This shows right here where the red circle is the high pressure steam line that's right at the section 7.02. It cross-references to an actual section that shows the location of that utility line within the tunnel. And then another piece of information in this diagram shows section 7.01 is cross-referenced to another table that then has height and width and other dimensional information about the individual tunnel section. So at this point, this is a sample of part of the tunnel network that's been created in the GIS, and this includes numbered vaults and directional cross-section points. These are cross-referenced to the previously shown data describing information about each segment of tunnel. So this information now is complete in the GIS database, and we're moving on to nailing down a number of the other utility features. And what we intend to do is to make this information available through secure web apps. This shows Campus 360 on the left with the login button highlighted. And it's shown on the right. Once logged in, additional layers and tools become available depending on the permission level of the user. In this example, the flyout window has 3 icons circled in yellow. Each corresponds to a different permission level. Selecting each of these will return different data within the window for the selected building. The preliminary access levels we've defined are shown above the map images. We have the security model in place for this functionality and will now begin to use it with data such as the tunnels. At this point, I'm going to hand over the presentation to Drennan Brown, and he's going to talk more about interior room mapping.
Thanks, Grant. Let me introduce myself. I'm Drennan Brown, Assistant Director of IT and Spatial Services here at Planning, Design, and Construction Department. And Grant did a great job on the overview of our enterprise GIS and the history of it and some of the current web maps and things that we've developed recently. And I thought it might be nice also to do a bit of a deep dive into something else that we're currently working on. With the recent consolidation of space management into PDC, which Grant mentioned earlier, we have a great opportunity to work on something we've long been interested in, and that is interior mapping. Our space management group curates around 1,100 CAD floor plans for about 230 main campus buildings. These are searchable on our website and served in both CAD and PDF format. Until now, however, we haven't had this kind of opportunity to fully integrate the floor plans into the GIS. So why would you want to integrate floor plans with GIS? And there's a whole lot of reasons, from asset management folks that might want to track where things are from their department, where these located, being able to highlight or support room and class scheduling, just basic location services showing where a room is on campus, to support RCM analysis, which is where departments need to manage and pay for their own space within their programs, scheduling the routing of workers as they move through space on campus, life and safety concerns for risk management and police services, a platform with which to create new and improved and flexible space analysis tools, and to have this all in the context of a relational enterprise GIS is one of our goals for this year. So hand building a couple of floor plans into a GIS layer isn't really that difficult, but trying to manage the sustainable creation and editing of over 1,000 really is. So we needed a way to find out how to automate this. Let me just overview a little bit here with what I'll talk about. I'm going to go over our automation process for interior mapping, what the building blocks are, how we leveraged what we already have, a little bit about georeferencing CAD drawings, and then I'll show you how the feature creation scripts work, which save us a lot of work. And after that, I'll share with you our demonstration apps and one that is in production. Let me start out with some of our building blocks. Our space management system is called Arquibus. Arquibus is a powerful space management tool used here at U of A to manage and report on space data. It allows basic access to data about rooms in space, but it's not connected to other spatial data, and it doesn't show any of the data in the context of our base maps. It's kind of one floor at a time. So this is built on top of our CAD floor plans, and as you can see from the graphic, the rooms are represented as polygons, and what we wanted to understand was how these CAD polygons are hooked to underlying data in the space database. So we started to examine this, and there are hundreds of fields in the space database that underlies Arquibus. So it took a little bit of detective work to discover that the key to this data was actually a combination of the drawing name and a unique value which is created in AutoCAD called handle. And once we found out this key, we knew that the automation would be possible, and that this key would be the foundation of how we would join GIS room features to the data. So there's a lot of prior work that's been done that nearly brings this all together. We just needed to start making the connections. Arquibus and CAD already have the room polygons that we want in the GIS, and these polygons are associated with data about rooms. Another one of our building blocks are that these very same CAD drawings have been previously georeferenced into our GIS for improving our building footprint layer and other uses. So georeferencing 1,100 floor plans is a fair amount of work, so we were glad to know that some of it, at least, was already ready to go. Just a quick note here about georeferencing CAD. In ArcMap, we can bring in one of the CAD floor plans and line it up with our existing building footprints by picking coincident points. This creates what's called a world file, which can be used to establish where the CAD file should sit in whatever the desired coordinate system is, in our case, Arizona State Plane, that our base maps and other features are in. With the important join key previously identified, and with all the CAD files georeferenced to our coordinate system, we're then ready to run these automation scripts. These scripts assume CAD files are named by building and floor. We make a batch file shown on the left for each building, and then the script on the right creates GIS features from the source CAD one floor at a time. The script then creates the join necessary to link up the new polygon features with the data in the space database tables using that drawing plus eHandle key that we had discovered. The result is that every room on the entire campus is represented in the GIS and can have other data linked to it now. So I have to give some credit where it's due with this, and that's with our colleague Matt Rahr in the College of Agriculture, who developed the basis for these scripts. We put together a Bitbucket repository listed here in case you would like to go there and see more detail about how these ArcPython scripts work. So this is a little bit about our goals with the interior mapping service. It's not really our intent to create all of the various applications that might leverage a GIS room service, but the goal is to primarily work on standing up a service that other developers on campus will be able to make use of. Some of our more advanced partners are already working with some of our beta level services, or they're in the early stages of planning. Facilities management is exploring the use of these services for potentially room inspection applications, custodial worker routing, shop order, and other workers that can be routed and mapped out what they're going to do during the day and the link within an application what duties they are to perform in the field. The College of Agriculture's Matt Rahr has been working with us pretty much on the entire workflow for the room and interior mapping, and has developed an application for using to trade space within his college. We've also spoke to the hazardous waste folks on campus, and they have an interest in creating applications to spatially record and report on the location and categorization of hazardous materials. So we got a head start with some of these folks, but in order to help the rest of the community along, we started developing a couple demonstration apps in-house just to show how the service can be used. This is called the Enterprise GIS Room Demo, and it's a very simple application that highlights how information shown here in green from the GIS service can be matched up against other sources of data. So a department may already have data that they've connected to rooms, and that's what we aim to show is possible with this application. There's an elevator tool here also on the left meant to show how one can easily flip from floor to floor. Another demonstration app, just a little demo thing here, is our Zoom to Room demo, and I've shown a real big close-up here to show. You can see in the URL that there's an argument up there for the room number and the building number, and when these are fed to the app, the user is zoomed straight into the room. So I can see a lot of applications for the Zoom to Room feature to be able to dynamically display a room, and I kind of hacked together an example here from our, this is from the university catalog, and shown here is a calculus prep course. You can see there's a field sort of in the middle there that it does list the room in the building, 412 and physics and atmospheric science, but the actual page doesn't have any graphic representation or mapping to this room because there really hasn't been any automated way to do that, and manually preparing that, it would be unfeasible. So what I've shown here with this mashup is that with our API, a developer will be able to programmatically and dynamically show users where any room on campus is. So those are our little demo apps. They don't have a lot of functionality. They're just shown to kind of demonstrate things and help developers see what's possible. But this here is a practical application that is already in use. This is the CALS Space Exchange shown here. This is developed by Matt Rahr at the College of Agriculture. And this app is provided to help connect users who want to obtain or let go of space. The app helps the users determine things like the room number, the square footage, who owns the space, and the need for this is largely driven by the responsibility-centered management model for budgeting, which is coming to U of A next year. So I've shared with you the vision for the interior mapping project and a little of what is going on currently. But here I'll share where we are in the whole process of interior mapping. We started in earnest in April of this year to provide a full campus service that would be sustainable and up-to-date daily. In the process, we found a lot of the source data that we needed to we found a lot we needed to address in the source data. And we have the GIS and space teams working together on standardizing all of these floor plans and data to be primed for automation. Sometimes more than one floor would be present in a CAD file, so we've needed to break each of those into individual floors, and we're nearly finished with that process. by bringing in the data into the GIS format and sort of presenting it in a different way than has been possible to see it before, some things that were not obvious have become apparent. Just kind of anomalies where maybe space wasn't completely recorded in the database, and since we've uncovered these, we're working toward fixing each of those anomalies. The scripts are working to automatically create these GIS features, which certainly automates the most tedious part of the overall process, but we still have some work to do on stitching this new service into our overall publishing process. So the goal is, ideally, we'll have a complete build each night to account for any changes to the floor plans or the room data. We also have a little more work to do on how the map service is presented as far as the default symbology and other display characteristics are concerned. And lastly, when we've got this ready to go, we'll need to start showing groups on campus the service that we've created and then teach them how to use it. So that's the overview of our enterprise GIS system here at University of Arizona. Grant went over a bit of our history, our organization, our current products, and future plans. That took us through a bit of a deep dive into our upcoming interior mapping service. And I'd like to say we're always interested in what others are up to and how others might approach a problem differently. So please don't hesitate to reach out to either of us to collaborate. And this was a great opportunity to share with all of you, and we thank you very much. I think this is the part where we'll open up to questions.
You are correct. Thank you very much. That was certainly a lot of information to process, and it's clear that you guys have put a lot of time and work into it. I know looking at the timeline, it was pretty neat to see that you guys date back to 1990, which is very impressive for me personally. So thank you for giving that detailed history of the department and sharing how you guys have grown and changed and evolved over time, and then also showing how you guys have spinned off into so many different areas of interactive mapping and really utility for the enterprise GIS. Very good, thank you. So at this time we will move into the Q&A portion of the webinar. If anybody has questions they have not yet submitted, please feel free to go ahead and send those using the questions dialog box, and I will pose those to the presenters for answers. So to start off, let's see. So in 2011, that's the date that you say the enterprise was like really created, right? You had taken attempts to move forward with enterprise solutions before that, but they weren't really successful. They didn't catch. Is that accurate?
The seed funding was 2009, and we started working on the maps and the database after that. And so I think our first map came out in, I believe it was 2011.
Okay. Okay. That's great. Now, do you mind going back to the slide that shows the web map applications where it's tracing the path from SDE Enterprise GeoDatabase to the web server and application codes? It was one of the first few slides, and then it shows the distribution to mobile devices. There are a couple of questions about that one. Yeah, absolutely, that one. So one of the questions was about the path of the information as far as the reasoning for the different logic and how you get to the end result. So specifically, for what reasons do you choose to publish the map servers through SDE and then to a file geodatabase to get to the map services rather than publishing from SDE to the map services? Is that a QC or a layer of protection?
Yeah, it's several things. One was we were wanting to have the web apps hit a read-only database, not the actual live edit database, which is the SDE database. So that was one reason. And also by exporting to the standalone file geodatabase, it allowed us to author our map documents against that data, QC it and so forth, and make sure it was looking right. And the other reason is that our enterprise database is in state plane coordinates, and as part of our export, we export to a state plane file GeoDatabase and then reproject that into WebMercator, which is the format that the web maps are in. So it gives us a WebMercator version of the database to use to mash up with other base maps and so forth.
Okay, gotcha. And so with respect to this workflow and what you've already mentioned or other components of it, what are benefits you see in this particular model, and also what issues have you experienced? Every workflow has its own issues.
Yeah, the benefits overall, it's worked fairly well, and it's allowed this kind of separation between the editing production GeoDatabase and the data that's serving the live web maps. The downside might be that it's a little bit, there's quite a few steps in it, and we have automated through scripts pieces of it, but the whole entire process has not been robust enough to be something that we press a button and it just runs and updates every single night. So that's meant that we've had sort of a longer gap between data refreshes than we'd like to, and that's one of the things that we're looking to remedy with some changes in the workflow coming up. So that's kind of, I guess, some of the pluses and minuses. Brennan, you have some items to add to that?
Well, no, that pretty much covered. It's a little bit of an all or nothing publishing situation. So when it comes time to update data, sometimes we have to make sure a lot of boxes are checked off. And like Grant said, we're working on ways to get to a daily write of the entire thing. And we have some other mitigating strategies, such as we may employ ways to directly update the file GeoDatabase, which the maps are hitting, rather than going through the entire publishing cycle for something like a small data update.
Yeah, that's been a challenge, is when we want to, if there's just one thing that changes on the one map, we're kind of bound to basically republish everything, and that's quite a bit of overhead to do just for one small data change.
Okay, thank you. Thank you. So it's neat seeing the campus needs supported in all the different areas and intentions you guys are tying into. Wanted to comment on that. I don't know if you guys have anything else more to say about that. There are no specific questions. I just really liked that slide in particular. It's a reminder of all of the ways that GIS can truly be used to assist with the various functions of various groups. Do you guys have anything else you'd like to say about that?
That was the diagram that showed all of the different applications.
The enterprise GIS in the center with the project delivery and public safety and operations and public info and student services, all of the things surrounding it.
Yeah, I think that's just sort of was a way to kind of capture this notion that at least as we've conceived of it, the enterprise GIS is touching on so many different aspects of how the university works, and so we're really thinking of it much beyond the focus needs, for example, of what this department needs, say, for just to support project delivery. It contributes to that, certainly, but we're kind of casting a broader net. So
another part of that strategy I would throw in was Grant went through the whole history of how we tried to get to where we are now, which thankfully is a sustainable strategy, but there was many years where we hadn't been able to achieve the sustainable strategy, so we're trying to get our foot in the door, pretty much as many doors as we could find. So Grant gets all the credit for making these connections with many different stakeholders across campus and getting their attention that GIS services could potentially do something for them. So in a way, we've started the conversation with every single group that you would want to have a full-fledged system with. So that's the groundwork that now you could say there's a chance we could actually fully deliver these things that we've been trying to get people excited about for years.
Yeah, and I'll say that that's one of the aspects of what Drennan says is, you know, we built this with very modest resources and to a certain degree gone out on a limb with building applications. So we've tried to offer it just as much as we possibly can without falling off the limb. While we want to be able to maintain the service, provide the service, keep the quality where it should be, but push it as far as we can. And so that's why now with you know, we do have a pretty broad group of partners on campus that have supported us. And now I think with our new resources, we're going to really be able to ensure that all of these services we've created are supportable and sustainable and robust.
Thank you. Thank you for elaborating on that. Do you mind to also elaborate some on the tunnel work you've been doing and the utility work you've been doing? I have a couple of just general interest questions coming in. So any detail you could provide in that would be appreciated.
Yeah, we've had some varieties of tunnel mapping for many, and actually some of the other utility maps for years, even going back to some old shapefile versions. And as I mentioned, there are a lot of different AutoCAD versions of various utilities, but the way they tend to be developed has been just for project-specific purposes. There's some initiative to get something drawn and sketched up, and then they have been put on the shelf, and they're not really being maintained as kind of information systems, you know, as living information systems for the future. And so because when the GIS was primarily located in the campus planning department, we really didn't have the connections and the kind of mandate we needed to maintain those systems. So we might develop a utility layer for a campus planning exercise in a district at campus, and then that would be set aside after that was done, and it would get old and out of date. And so now with being located within planning, design, and construction, there's a definite kind of business need for having this utility information. So even if we're not part of facilities management, we're not out there maintaining and managing these utilities day in and day out, but from a utility planning and project development standpoint, we do have a need to know where these utilities are and what the basic components are. So that's given us kind of a new mandate to develop this information, and we've chosen to develop it in the GIS as a best tool for actually managing the information going forward. So right now our strategy has been to get the tunnels nailed down first, figure out clearly what's in them, and off of that then start to build all of the individual utility lines for electric service, for water service, gas, and so forth.
Okay.
Does that help give a little more overview that you were looking for?
It does, and I think that answers the questions that were coming in as well. Thank you for that. I think you should expect to be contacted after this as well in that regard. So a heads up for you.
Sure, no problem.
Yeah. Okay, so with respect to interior mapping, did you create a GIS data model to manage your interior space, or did you use Esri's model?
Well, I guess you'd say it's home built, and it's definitely not finished. So working with what we have, kind of going back to those building blocks, we want to leverage what we've got here. So we're starting with a polygon that when you click it, that at least the polygon would know what room you're talking about, and that's basically the foothold to click to attach other data to it.
Okay. Thank you. Go ahead.
I'll just say I've reviewed the Esri data model and some of the other models too, and I think that we may, as we kind of advance this, we might move into more of a standardized model. But as Drennan said, we're kind of really building the elemental pieces to start with, which is sort of fundamental, and then it can go in a variety of directions.
Okay, thank you. Another question, with the space exchange map, it's neat how you showed how it's good for swapping spaces, and I can see there would be a lot of infrastructure that would be needed to invest in that to get it to that level. I'm curious, are there any reporting is there any utility in reporting issues? So if this room number is incorrect, or if this person is occupying a different space than the one indicated on there, that are built into the map?
Not yet, but that is probably the first practical in-house application that we're going to develop on top of these room services. As we talked about earlier, the space management group is now merged within our department, and keeping accurate track of that kind of information, so that is actually our responsibility now. And the existing tools in Archibus for, let's say, self-reporting or correcting that information is very limited. And extending that application is not so easy since it's a closed system. So we are envisioning an application kind of like what we have up on the screen here, where the occupant of this room would be able to click it, see how it's identified, and basically correct the errors, and that would stage them for being updated. They would of course be reviewed, but we do want to push that self-correction effort to allow departments and individual users to contribute to the improvement of the data.
Gotcha. Now, if you are able to do that, will you implement any levels of quality control for that, or have maybe specific users in each department that are given the knowledge they need to make those changes, or will it be more of an open source solution for whoever that needs to use it, really?
Well, the idea so far anyway is that either specific individuals within the department, or perhaps a complete crowdsourcing sort of idea, may be allowed to propose edits, but that those would simply be staged for our space management professionals to review and then release or modify prior to performing the actual update.
Okay. All right. Well, thank you very much. We're at the end of the webinar now, so we're going to wrap up. If we weren't able to get to your question today, please do feel free to contact Grant or Drennan after the webinar, and their information is available on their final slide, I believe, and then also available online. Thank you to all of our attendees for joining us today and for joining us in this 2016 webinar series. This is the final webinar in the 2016 Geotech Showcase, and I have to say I'm really pleased with how this webinar has grown. It's been a wealth of information and it's been very openly shared, so a lot of appreciation for all of you presenters and attendees for participating in this showcase. Stay tuned for more information on a third annual showcase in 2017, and for more information on future webinars and CFTA, please visit the website at www.cfta.org. Thank you.
Thank you.
Thank you.